Problem 2016. We have a battery with a solenoid and a switch, and a second solenoid next to it connected to a resistor. Part A asks you to find the direction of the current flow through this resistance when this switch is just closed. Well, before the switch is closed, there's no magnetic fields anywhere. But after the switch is closed, according to this battery, if this is the plus end, the current should flow up that way, up behind this solenoid, and then down in the front, back up behind, down in the front, up in the back, down in the front, down in the front this way. So this solenoid creates a magnetic field. If I hold my right hand this way, current flows down in the front, my thumb points to the right. So the magnetic field from this solenoid points to the right, and that's the magnetic field that goes through the second one. Now, the switch was open at first and there's no magnetic field. Now the switch is closed, so there is magnetic field. Therefore the flux here is increasing. So the magnetic field created by the induced current in this solenoid should oppose the magnetic field from the first solenoid, which in this case would be to the left. So if the magnetic field created by the induced current here is to the left, I point my thumb to the left, my fingers curl around it this way, up in the front and down in the back. So up in the front and then down in the back. This wire goes down behind, comes that way, and right to left through this resistance, and then back up and up in the front. So for part A, the current flows right to left through that resistance. Part B, may want to know, for the same situation, what happens when this switch has been closed for a long time. Alright, if this switch is closed, we have current still flowing the same way through that solenoid. We still have magnetic field pointing to the right. But if that switch has been closed for a long time, then this magnetic field to the right has been there for a long time and is not changing. So if this magnetic field is not changing, there's no change in flux, therefore there will be no induced current. So for part B, nothing flows. Part C, now that we've closed the circuit and let it sit there for a while, we want to know what happens if this switch here is opened. Well, initially anyway, the current is still flowing the same way it was before, and that means we still have a magnetic field to the right initially. But when this switch is opened, the current will stop, and the magnetic field will go away. Therefore, the flux through this solenoid is decreasing, so the induced current will make magnetic field to the right to try to keep that flux from decreasing. So if that magnetic field is to the right, let's see, my fingers point up in the back and down in the front in order for my thumb to point to the right. So if the current is flowing down in the front, that's down through this wire, left to right through the resistance, and then over here, back up in the back. So for part C, when we open the switch, current through this resistance is left to right.